All right, we're going to look at question 8 first. Now, first thing is we're looking for the domain. So the domain. So what is a domain? The domain is where what values of x must be. What values of x must be. Now, square root of x, in order for this to be valid, x needs to be greater or equal to 0. Is greater than or equal to 0. If it is less than or equal to 0, the whole thing becomes invalid, becomes undefined. Now, the second part we have is 4 over the square root of x. Now, normally when you look at the square root of x, the domain is x is greater than or equal to 0. But in this case, if x is equal to 0, this whole fraction is undefined. Therefore, we cannot use that. Therefore, x is greater than 0. Then we combine these two. We look at it. Okay, well, overall, the domain, in this case, the domain will be what? The domain will be x is greater than 0, not x equal to 0. That's the domain. Then the very next thing, what we're going to do is to find the derivative of f dash of x, basically derivative. Now, step number 1, what we're going to do is we are going to rewrite the function. We're going to rewrite the function as square root of x minus 4 times square root of x bracket negative 1. So what we're doing is we're using the 1 over n is equal to 1 times n to the negative 1 power. So then we know square root of x is x to the power of half. Now I just rewrite that. That's x to the power of half minus 4 times x to the power of half negative 1. And then we can just do the index rules goes, that is that minus 4 times x to the power of negative a half sinks negative 1 times that is negative a half, because when you take out the brackets of the index rule, you have a half times negative 1. So that is the function. That is the function. All right. Then once we have this as the function, then we can do our f dash of x is equal to, we use the rule. Remember, what's the rule? The rule is, I'm going to write it next to you. So when fx is equal to x power of n, then f dash of x is equal to nx power of n minus 1. In this case, I'm going to do, it's a half, which is n, then a half minus 1. Don't forget about minus 1. A lot of students will actually forget about that. Minus 4 times a half, then x to the power of a half, again minus 1. Bracket. Then we simplify it. Once we simplify this whole thing, is a half x to the negative a half minus, so that's actually plus 4 times a half, that's 2x to the negative 2 or 3 over 2, if you do it that way. And then we can do some other thing. Now here, if we simplify this, if we can simplify it, we'll do the simplify next. Why? Because part C is state the domain of f dash of x and explain why this must be the case. Now, so this is interesting because when we simplify this, I'm going to rewrite it as, bring it back. So I'm going to have a half times, this gets interesting, 1 over square root of x. That's what that is. Okay? Plus 2 times, this is where it gets interesting. So it's 1 over x to the power of 3 over 2 to the power of 3 over 2. I'll just write it like that. I'm not going to bother to write as x to the power of 3. Just give you a quick with that is x squared that. But I'm not worried about that. I'm just leave it as it is. So in this case, when we look at it, when we do part C, right? When we do part C, we can see, okay, well, now we have a problem because the stuff that I need to worry about, part C is that, and the other thing I need to worry about is this. So to make that valid, x it need to be greater than 0. Bracket it up. To make this valid, x cannot be equal to 0. Okay? So basically, x is greater than 0. Again, that's the domain of f dash of x. Now, when I simplify this, just to give you a quick answer, when I simplify f dash of x was previously from the previous C, it was like this. Now, when I simplify it, it's actually x plus 4, 2 to the power of x, 3 over 2. If you want to simplify this, it takes some time to do that. And then we're going to do part D. What part D is asking, it says, okay, find f dash of 1 and explain what it means. So f dash of 1, as we know that, so f dash of 1, that's easy, which is 1 plus 4, then 2 times 1 to the power of whatever that is. I don't really care in this case. So, because 1 to the power of whatever is still 1. Therefore, it's 5 over 2. It's 5 over 2. What that means is at x equal to 1, the gradient of the slope is 2.5. Okay, what does that mean? Means when x increase by 1, when x increase by 1, f of x in the function, the value of the function increases by 2.5. So when x is increased by 1, fx is increased by 2.5. So this covers question 8.